bench power supply using ready-made modules. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. This project started with the intention of modifying an old power supply that, in its original configuration, had become useless. However, in the end, only the case was reused, and the original electronics were put aside. The plan was to use ready-made DC to DC power supply modules, each one powered by an old laptop power supply. 2 modules for low voltages and 1 for high voltages were planned. These are the chosen modules, including the meters for the high voltage output, powered directly from the mains. Taking for granted that the modules would function as expected, which later proved to be unwise, the adaptation of the case starts. 2 fans will be put inside the case to make sure that there will be enough heat dissipation from the DC to DC modules. The imperfections are initially adjusted by hand, then with the aid of a small electric screwdriver. Four holes at the bottom of the case are enlarged to allow using zip ties for holding the 3 old laptop power supply units. The wires for the input power are soldered directly to the sockets, and some extra insulation is added. The lower part of the case is slowly populated, starting from the AC input from the mains. The AC input is connected straight to the 2 fuses. The 3 laptop power supply units are installed as planned. The DC to DC low voltage regulator is adapted. First, the 2 trimmer resistors are removed. They will be replaced with potentiometers. Then some extensions are made for the potentiometers. At the moment, only regular potentiometers are connected for testing the voltage regulator. Later, multi-churn components will be used. The regulator is tested. The output voltage can be easily set, visualizing it on the embedded display. The display shows only the actual current that is flowing. Therefore, at the moment, without external load, it is possible to see only that when the max current potentiometer is set to 0, the unit also drops the output voltage. The high voltage module is adapted in the same way, but not tested yet, for safety concerns. The high voltage module is going to be installed on the lower part of the case. Therefore, the cable coming from its power supply is separated from the others and shortened. The high voltage module has nylon spacers to reduce the chances of shorts with the metal case. The module is finally tested, and at the moment it seems to operate sufficiently well. The plan is to populate the lid of the case with the low voltage modules and the meters for the high voltage supply. The most important holes to be made are those for the meters. Therefore, they are prepared first. Then the other holes are made, in particular 2 large ones, for the view of the built-in display of the low voltage modules. Because it is possible, they are just round holes. When all the holes are made, the components can be installed and connected. The large round holes need to be covered with some clear plastic. This one was recovered from some packaging. All the connections between the parts located on the lid of the case and those that are placed on the bottom need to be easily separable. Therefore, automotive spade connectors are used. With the wrong assumption that the high voltage module could provide two independent outputs, one positive and another negative. 2 meters were planned and connected accordingly following this schematic diagram. The 2 meters are powered directly from the mains, therefore they are internally isolated. The bottom and the lid of the case are joined using spade connectors, but the wires are kept longer than strictly necessary and loomed together in two groups: mains and low voltage supply. High voltage supply. The unit is turned on using a dim bulb tester, and it is observed that the current drawn by the high voltage module is intermittent when it is set for relatively high voltages. The low voltage modules seem to be working correctly as expected. Here is how this power supply is supposed to be installed on the bench, which explains the need for longer wires connecting the two parts of the case. Testing the low voltage modules under load, they appear to operate correctly as expected. Unfortunately, the high voltage power supply does not behave exactly as expected. The negative high voltage cannot be used independently as originally thought. The exact behavior will be explained in a later section. There is one important thing to observe at this stage of the test. If only the positive segment of the high voltage supply is used, the negative one can reach higher negative voltages below -400 volts. The high voltage module can provide only a limited output current. There is no regulation for the maximum current, but when the limit is reached, the voltage drops. However, with the original components on the module board, the final rectifier diodes fail very easily. The high voltage module is known as YH11068A, and a schematic diagram is available at this Russian online conversation group. It is available in two versions. With a single high voltage output, or with a double high voltage output, like the actual module used in this project. The circuit is capable of controlling only the first output voltage, while the second part, if the components are installed, comes along, but only if they are traversed by the same output current. In other words, the load could be applied only between the first high voltage output and ground, and in this case a voltage between about 50 to 350 volts could be obtained, or between the first and the second high voltage output, and in this case a voltage between about 100 to 700 volts could be available. However, if only the first output is used, the voltage on the second part would fluctuate out of control, very likely significantly exceeding -400 volts. Unfortunately, this would put the corresponding filter capacitor in a condition of severe stress because it is rated only for 400 volts. Based on the tests that have been done, when the output is loaded, if the output current exceeds a certain level and the circuit has to compensate for coping with the request, the original rectifier diodes have the tendency to short. These are ultra-fast rectifiers rated for 1000 volts, 3 amps. Using instead diodes HE or 508, which are rated for 5 amps, it was possible to avoid this failure. The final test is done using a load of 30 kilo ohms, measuring the output voltage also with a multimeter. As already explained in the previous section, when the load is applied only to the first high voltage output, the voltage of the second one can rise out of control, well beyond -400 volts. When the load is applied between the first and the second high voltage outputs, all seems to work well. If I had understood how the high voltage module behaves, before drilling the case I would have made a single output using the positive and negative ends of the high voltage with one single meter.